So what we've done with Cisco is we've created a partnership around integrating our chargers with their HEC home energy controller and home area network. So what we want to be able to do is offer EV drivers a chance to get into a demand response plan, a chance to integrate into a time of use program, and really help them better understand how to use electricity and how to more effectively manage that. Consumer education here is going to be a big, big piece for us as we move forward here and try to make sure that, again, that charging an EV is something that's safe, that's practical, and something that's good for really the overall grid as a whole. I mentioned that we also have a lot of work with ABB. ABB is GE's largest global competitor. 80% of all transformers in the United States are of ABB heritage. Interesting little fact there. But they provide everything from the SCADA systems for utility, distribution, transmission. And right now, where we are on this level here, we're their endpoint to talk to consumers. We're going to people's homes, we're controlling that load. So what we're working to do with ABB is make sure that we are integrating our charging stations all up to the demand response management system, the RMS of the utilities. That way, when we need to shed load, we essentially have a lot of these devices out here that have the capabilities to charge at up to 6.6 kilowatts that we can either turn off or turn down if the consumer is part of this program. Most people in California know blackouts are a big issue here. So as long as we have, I believe it's 48 hours during the year, which we actually implement these programs, the ability to turn down or turn off that charge in those 48 hours, we can offer those consumers a much lower rate. And we believe that really is where this whole industry is going. To take another step, we're going to know commercially, at commercial locations, we're going to have a lot of data. So we're going to understand where an EV driver, or really where a car swipes every time they swipe and use our charging station. What that means is I'll know at a commercial intersection, this charger is most often used from 1 o'clock to 4 o'clock. It often pulls X amount of kilowatts from the grid. Utility pleads a lot for 6 kilowatts per hour being charged at this location. If you want to, we have intelligence, we have communications, and a way to message our consumer. We can tell them that at this point in time, you'll only get 3.3 kilowatts worth of electricity, and you'll have a different rate to charge that. We will tell them that on their smartphone, so they'll know what to expect when they get there or when they reserve that charger. There's really a lot of things that we can do to really make sure that EVs are a solution for the grid. The other one that you'll hear about, I don't have a slide really to talk about, is in the vehicle to grid. You're going to hear a lot of people talk that I'm going to use these cars and I'm going to charge them up at night, and then during the daytime I'll put them back to my facility to really mitigate some of my load and my demand. We're doing the only test right now, DOE-sponsored test on vehicle to grid. And the issue that we're seeing right now with vehicle to grid is battery life. Batteries have improved dramatically over the last decade, but right now they're not the silver bullet just yet. We're getting there, and we believe we'll see vast improvements in batteries, in power density, and cost. That's going to make it much more affordable than vehicle to grid. But right now for vehicle to grid, the question is, do you want to waste a cycle, which could bring you to the office, that could bring you to SeaWorld or wherever you're going, on, say, powering your toaster or powering your television or whatever that may be when you throw it back into your home, versus getting you where you need to be. And right now, we're seeing cars that have anywhere from 4,000 to 10,000 cycles, depending on how the driving behavior occurs. The cost benefit of that really doesn't make the most sense. On top of that, you're going to have to rechange the entire leasing model and vehicle ownership model when we start doing the cycle life, because it's going to, when you do vehicle to grid, it's going to affect how people use their battery systems and how OEMs can warranty that. So we see a lot of promise in vehicle to grid. We see a lot of promise in vehicle to grid in material handling and airport, ground support equipment, and larger fleet applications. But we believe that's probably 5 or 6 years off, at least, before it starts becoming a practical consumer type of application. So I think with that, that kind of wraps up my presentation.